So next up is the dot product of two algebraic vectors. So in our last video, we looked at the dot product of two geometric vectors, which you can recall is a dot b is equal to the magnitude of a times the magnitude of b cosine of theta, where a and b are any two non-zero vectors arranged tail to tail, and theta is the smallest angle between a and b. The dot product of two algebraic vectors, given that a equals a1, a2, a3, and vector b is b1, b2, b3, so the dot product for two algebraic vectors, a dot b, is the multiplication of the two x components from vector a and b, plus the two y components from vector a and b, plus the two z components multiplied together from vectors a and b. In the next part, we're going to prove that this is the formula for the dot product for two algebraic vectors. So first of all, let's look at the diagram to the right. We have vectors a and b with angle theta between them. And if we look at vectors a and b, I've drawn vector c, which is equivalent to a minus b. So if I drew minus b this way, we see that we can travel this path, negative b and a, and that would be the same thing as this path c. So negative b plus a, or a minus b, is equal to vector c. So let's use that information. So first of all, we're given that a equals a1, a2, a3, b equals b1, b2, b3, and c is equal to a minus b. Alright, if we subtract a minus b, we're left with a1 minus b1, a2 minus b2, and a3 minus b3. So we now have vectors a, b, and c. Since we have vectors a, b, and c, and this angle here, we can relate these four quantities using the cosine law. And we're going to call this equation number 1. So again, from the diagram, we see, using the cosine law, that the magnitude of c squared is equal to the magnitude of a squared plus the magnitude of b squared minus 2 magnitude of a, magnitude of b, cosine theta. Let us determine the values for the magnitude of a, b, and c. The magnitude of a squared is equal to a1 squared plus a2 squared plus a3 squared. And therefore the magnitude of b squared is equal to b1 squared plus b2 squared plus b3 squared. And finally, the magnitude of c squared is equal to a1 minus b1 all squared plus a2 minus b2 all squared plus a3 minus b3 all squared. And we're going to need to expand and simplify c squared. And you can do this yourself and then check your work. So there's the expansion of c squared. And we're going to call this equation number 2. And we're going to sub this all into equation number 1. So let's see what happens. So then we know that the magnitude of a squared plus the magnitude of b squared minus 2 magnitude of a, magnitude of b, cosine theta is equal to c squared. But we're going to sub in c squared. So we end up with the following. So next, let's rearrange some of our terms. So I'm going to group all the terms with a together. So I have a1 squared plus a2 squared plus a3 squared. Then plus the b terms, b1 squared plus b2 squared plus b3 squared. And those should look familiar. And I'm left with minus 2. And notice I have a1 b1 plus a2 b2 plus a3 b3. So I took all the ones with minus 2 in them. So I took all the ones with minus 2 and factored out the minus 2. Now let's go from there. So I have the magnitude of a squared plus the magnitude of b squared minus 2 magnitude of a, magnitude of b, cosine theta. Notice that this is the magnitude of a squared, this is the magnitude of b squared. So on the right side I have the magnitude of a squared plus the magnitude of b squared. Then I have minus 2 a1 b1 plus a2 b2 plus a3 b3. Now if you look here, the a's will cancel, the b's will cancel, and I'm left with negative 2 magnitude of a, magnitude of b, cosine theta is equal to negative 2 a1 b1 plus a2 b2 plus a3 b3. Cancel out the minus 2's, and you should see something on the left side. We have the magnitude of a, magnitude of b, cosine theta, and on the right side I have a1 b1 plus a2 b2 plus a3 b3, and this here should look familiar because that is the dot product. So we end up with a dot b is equal to, and notice we now have our formula for the dot product of two algebraic vectors. So example 1. Triangle ABC has the following three vertices in 3 space. Negative 2, negative 3, and positive 4, negative 1, negative 4, and 5, and 3, 4, and 2. We'd like to determine angle A. So let's quickly draw a picture. Again, it's not accurate, but it just gives us a visual. So we have A, B, and C. And I want to know angle A. And of course, we could find the lengths of all 3 sides and use the cosine law. But there's a much quicker way now. We can now use the dot product. First, we need 2 vectors. So if I take vector A, B, and AC, notice the angle between them is angle A, or theta. We can combine both the algebraic and geometric dot product. We have the magnitude of A, magnitude of B, cosine theta is equal to, remember our dot product is defined as A1, B1, plus A2, B2, plus A3, B3. So all we need is vector A, B, and AC, and we can sub it into this formula, and we can determine the angle between these 2 vectors, which is the angle in the triangle. So let's start with vector AB. Remember that is OB minus OA. So in this example, that's negative 1, negative 4, and 5, minus 2, negative 3, and 4, which tells us that vector AB has components negative 3, negative 1, and 1. And if I want the magnitude of vector AB, remember that is just the square root of negative 3 squared plus negative 1 squared plus 1 squared. And that tells us that the magnitude is equal to the square root of 11. Alright, the next vector we need is AC. And I'm just going to skip to the components. So AC would be OC minus OA. So that would give us 1, 7, and negative 2. So we have 1, 7, and negative 2. And then the magnitude of vector AC is equal to the square root of 54. So now let's use the dot product to determine our angle. So our vector A, we'll say is this vector here. Here's our vector B. So the magnitude of vector A, well, we know that's the same thing as AB, so that's the square root of 11 times the square root of, we go back to AC, that's 54, cosine of theta. And then we need to multiply the x's together for both the vectors. So we're going to multiply this x by this x. So negative 3 times 1. Negative 3 times 1. Then plus this y by this y. So negative 1 times 7. And then plus 1 times negative 2. So now we have cosine theta is equal to negative 12 over the square root of 11 times the square root of 54. And now we can find the angle between the two vectors, or angle A. So that would be the cos-inverse of negative 12 over the square root of 11 square root of 54. And using your calculator, you can approximate this angle to be 119.5 degrees. All right, last example. So what values of k are the vectors u and v perpendicular? So again, our keyword here is perpendicular, and we know that the dot product of two perpendicular vectors is equal to 0. So we're going to start with that. So u dot v is equal to 0. So we have k, and minus 3 dotted with k, negative 3 and 6 equals 0. If we use our dot product, we're going to multiply the two x's together, so that's going to give me k squared. The two y's are going to give me negative 3k, and then minus 18 when we multiply the two z values. So we need to solve this quadratic when it equals 0. So first of all, we need to factor this quadratic. So that's going to be k minus 6 and k plus 3. Those two numbers, negative 6 and 3. Add to negative 3, multiply to negative 18. So we end up with one value of 6 and one value of negative 3. And we are done. So those are the two k values. So how do you check your work? All you need to do to verify is to show that the dot product equals 0. So let's start with k equals negative 3. That means our vectors u dot v would be equal to negative 3, negative 3, negative 3, dotted with negative 3, negative 3, and 6. And if you dot those, you will get 0. And the next one is k equals 6. So u dot v is equal to 6, 6, and negative 3, dotted with 6, negative 3, and 6. And again, if you dot those, you will get 0. So this verifies that k equals negative 3 and k equals 6 are both solutions to this problem. Again, here's some questions that you should try, and good luck.